Yeah, hi everyone. Hi Stockholm. I'm so excited to be here, and thank you for choosing to come to this stage in particular. Now, AI-powered mapping and automation, or automating HD map feature creation for autonomous driving. That's a mouthful. Um, Today I'm going to be speaking about how we're building standard definition map features, SD features, how we're building high definition map features, and how we're building SD map features by deriving them from HD. And really, I'm going to be talking about how good engineering practices, architecture, iterative development, and deduplication efforts all help us to overcome the challenge of innovating while maintaining production systems, and ultimately help us build an AI-powered HD map at scale. So, we need to build HD map features at some acceptable quality. What that quality is a bit of a moving target, but that's the ask. So SD features were built, that was or at least some of them, the mandate at the time, and we had to start building these HD features. Now, automation, so read AI, deep learning models, extraction models, algorithms, etc., is crucial because while we can and we are making HD features with manual operators, that doesn't scale, right? It can be done for very limited areas, but it doesn't even scale to city scopes. It doesn't scale to country scopes, and it certainly doesn't scale to world scope. So AI and automation is crucial. And operational excellence also ties into our ability to scale because if data is shared on Slack and you need like a specific engineer to manually run certain processes, that's not really a reliable or scalable system by any means. So at the same time, we can't just like dive headfirst into innovation and forget about KTLO, right? Maintaining existing systems and our existing customers. And balancing maintenance of production systems and taking care of existing customers while innovating and building new features is difficult. Famously difficult. If we put too much effort into perfecting or ever expanding the features we have in production, then it's difficult to find time to innovate and think about new approaches or new architectures. But if we put too much effort onto innovation and neglect our paying customers, then we run the risk of letting systems fail and fall apart, and we might lose the trust of customers we have before we have a better product to offer. So that's the challenge. And to me, it's a little bit funny because, like, if I talk to people in the business world, people with MBAs, executives, etc., several people have told me yeah, doing R&D and innovation while doing maintenance, it's very difficult. It can't be done. Like, no one should do that, basically. But from a software engineering perspective, that's what we're asked to do. So I'm no management scholar. I'm just an engineering leader, but I'll talk about how we approach this problem. And yeah, why bother? What's the motivation? Why care? I think for me, I care about maps, period. I care about location technology because it underpins so many applications. And sorry, just making sure I have the right slide up. Um, and yeah, I work in ADAS and features for autonomous driving specifically, use cases like which traffic light box controls this specific lane, or where exactly does the car need to stop in this upcoming junction. Those are the kinds of problems that we deal with. But really, we're building a digital representation of the world. And only a handful of companies build maps, but almost everyone needs one. So, yeah, and hi everyone. My name is Flament-Wallin. I am an engineering manager, like I said, in the ADAS team at TomTom. And for the past 2 years, my team has been building what we call road furniture features. Those are basically all kinds of objects on and around the road, your traffic signs, lights, tunnels, bridges, etc. We started out building these in SD. Now we also build in HD. It's a fascinating project and process, and I'm excited to talk about it. So yeah, this is how we built SD map features. And it looks pretty simple. Basically, we have a couple of sources that are important to us. For example, sensor data from cars driving all around the world and observe the road and the things on and around the road. And we have higher quality data sources like LiDAR scans and panoramic images of the road. There are other sources that are important for map making as well, like aerial imagery. But those are not as useful for things like, for example, traffic signs, because we need the face of the sign to be able to extract the semantic meaning of the sign, for example. Anyway, so for the sensor-derived data, we aggregated and clustered this data to get one observation, which is what we care about. And there was a computer vision model, extraction model to extract the signs, etc., from panoramic images and LiDAR scans. And then we had a fusion algorithm, a k-nearest neighbor, pretty simple algorithm to take these several sources and make one piece of knowledge. And once we have that, we match it to the, excuse me, to the SD base map. So what that looks like is that the SD base map has a center line of the road, and we look at the traffic sign, and we see that, okay, based on the location of this sign, based on the directionality of the sign, we decide that this sign belongs to this road and not this road, like, for example. And once we've done that, we build the map feature and we publish it to a map layer in our platform that can then be consumed by downstream customers that use our sign knowledge to create things like speed restrictions, or they can be compiled in the actual map and used by ultimate downstream users in their cars, or to visualize whatever. So that's the process. And then we had to start building HD map features. And it looks something like this, which, as you can see, is pretty similar. So the data sources are the same. There is a new extraction, deep learning extraction model. There's a feature store now with more details, because we need things like elevation, not only long latitude. Sorry, excuse me, I have a bit of a cold. Oh, yeah. And a 3D bounding box, because HD features are more like 3D objects. And a not so small detail, we are now map matching to the HD base map with, instead of just a center line for the road, that has lane level information. and then we build the feature and publish it. But in practice, the process is the same. So as you can see, that leaves us with 2 pipelines, which is not ideal. Oh my god, excuse me. Yeah, this is not an ideal scenario, and I think there's 2 main problems with this. So, first of all, any engineering leader, right? I think we have at least one senior engineering manager in the audience. Will look at this and see duplicate efforts. So there are in every single process and everywhere, there are details and possible improvements to every model, to every library, etc. And if we keep maintaining both, they're going to keep diverging, and it's going to be harder and harder to maintain, at least for one team. And another thing is that it doesn't make any sense, because HD features is a superset of SD features. Or the other way around, SD features is the subset of HD features. So really, it should be unnecessary to build these features twice in separate pipelines. Another issue is that with 2 separate pipelines, there is no way to trace these 2 features to each other, which is strange because an SD traffic sign is the same HD traffic sign in reality, right? And this is also what customers expect, to seamlessly be able to switch between the 2. So, for example, we have sorry. We have an area with HD coverage, and then the car goes into an area where there's only SD coverage. Then ideally the car, the driver, or whatever shouldn't really notice the difference, other than that, you know, it's not as detailed anymore. But it's the same like sign they're looking at, for example. And as a company, since we build both SD and HD maps, there's no good excuse really to not be able to do this. So what we need then is something like this, which is one pipeline that builds the HD feature first, because that's the superset, and then derives that to SD. So what that means is, for example, in the map matching algorithm, we will map match to the HD lane, and then we'll need some kind of fallback mechanism to map match to SD where we don't have HD coverage. And then we build the map feature, and then we publish that as an HD map features, HD map feature. And once that's done, then we can derive that to SD with something that we call the crosslink, which basically is a storage of the mapping between an HD lane and its corresponding SD road, which is the difference between HD and SD in the base map. And then we can build that and publish that. So we are building a unified HD first pipeline with derivation to SD. And next steps are things like plugging in more sources. And as we get more sources, and we are multi-source, we need a sophisticated fusion algorithm. And then there's things like change detection and incremental updates. Because one thing is to build a map once, and then another thing is to update the map. That is a different and maybe more difficult problem. And then we have things like, a minute or a second or even near real-time updates. And then we'll have other problems like if a traffic sign, if the source says that the speed is like updating every 30 seconds, how do we decide if the reality has actually changed? Obviously, we can't check that manually. And do we, as a company, as a team, whatever, only care about mapping the reality, the world, or do we also weigh things like user experience and safety, for example? So that's next. And just before I finish, I just wanted to say that maps are for everyone. Our Orbis platform is for everyone. Everyone can build map layers or use location data to solve problems for their customers. So please do that. And yeah, thank you for listening.